Welcome to Chemistry Lab. Today's lab, titration of a strong acid and a strong base. You've done titration before. Earlier in the semester you did a potassium permanganate titration. Remember the purple stuff? We're doing the same thing again, but today we're going to put a strong base in the burette and an acid in the beaker below, and we will titrate one into the other. A titration is the process of slowly adding one reagent to the other until an endpoint is reached. In this case, the endpoint is when the moles of acid are equal to the moles of base. Pause. The reaction, when the strong base, hydroxide, is reacting with the strong acid, of course, it forms water, which we think of as being pH neutral. Of course, water auto-ionizes into equal amounts of hydronium and hydroxide, which is why we expect our equivalence point, the point at which moles of acid are equal to moles of base, to be pH equal to 7 in the case of a strong acid with a strong base. Our experimental goals are these. 1, we're going to make the sodium hydroxide solution, 0.2 molar sodium hydroxide solution. And what we have in the stock solution is a 6 molar solution. So you're going to have to dilute that. Use your dilution equation to figure out how much you need in order to make the amount that's required. The second goal will be to standardize the sodium hydroxide solution. What that means is to determine the concentration of sodium hydroxide to at least 3 significant figures. You're trying to make a 0.2 molar solution of sodium hydroxide, and the dilution procedure you're using to do that is really good to 1 significant figure. But we need to know to several significant figures, at least 3, what this concentration is. So the process of standardization is the process of recalculating that concentration. After you've done that, you're going to make your hydrochloric acid solution that you need. And once again, you'll need to dilute that down appropriately. And then the last thing that you will do is to titrate the hydrochloric acid solution with the sodium hydroxide solution, and then determine the molarity of that solution. That's your ultimate goal here, is molarity of HCl. Begin. For the standardization process, you're going to be titrating the sodium hydroxide solution that you've made with a different acid. It's going to be a solid acid called potassium hydrogen phthalate, which we abbreviate KHP. And this reacts with sodium hydroxide in a 1-to-1 ratio. 1-to-1 ratio. In other words, if this is the acid, then for every 1 hydrogen ion, it will react with the 1 hydroxide ion in sodium hydroxide. Now, question number 1 in your lab manual asked you how much KHP you should weigh out in order to use approximately 20 milliliters of solution from your burette of this particular solution that you've made of sodium hydroxide. To think about this, KHP is a solid acid. You're going to weigh that out. So you know how much all of this weighs. And the molar mass of KHP is given in your lab manual, so you can find the number of moles. Now, when you do this reaction, you're going to have the acid in the beaker, and here's your burette. That's where the sodium hydroxide is going to be placed. And so you're going to do the titration, and you're going to titrate to what we call a phenolphthalein endpoint. Phenolphthalein is an indicator that is clear in acid or has no color in acid, but as soon as it has just reacted with all of the base that you've added, it turns a light pink color. So you're going to add sodium hydroxide to the KHP, acid that's dissolved in water with a little bit of phenolphthalein until 1 drop of sodium hydroxide turns this a light pink color. At that point, the number of moles of sodium hydroxide are equal to the number of moles of KHP. So you weighed out the KHP, you can convert grams to moles, so you know how many moles of acid are in this container. And when you get the light pink color, you also know how many moles of sodium hydroxide have to be in there. And you have the burette where you can read the volume markings. So you can find out if you're using exactly what volume you are using, and you're going to be using that to determine the molarity of the sodium hydroxide. For question number 1, if you know the volume you want to use, which is approximately 20 milliliters, but we're going to say 20 milliliters for the sake of answering question number 1, and if you know the concentration is approximately 0.2 molar, you can use that to say molarity times liters is equal to number of moles. And at the end point, moles of sodium hydroxide and moles of KHP are equal. So you can use molar mass to convert moles to grams to find out how many grams of KHP you should use. So after you've answered question number 1, you've made your sodium hydroxide solution. You need to go about standardizing that sodium hydroxide solution by carrying out essentially what we described here in question number 1. You're going to weigh out a certain amount of KHP. You're going to put your sodium hydroxide solution in the burette, and there's some instructions in the lab manual for rinsing the burette. And don't get too caught up in this, but you just put a few milliliters in the burette and you let it run through, and you kind of tilt the burette to the side and kind of make sure that it's filled with sodium hydroxide solution instead of leftover water solution. So you do that a couple of times just to sort of clean it out with your solution, and then you fill it up. Remember, you cannot go over the 0 mark, and you do not have to start at exactly 0.00 milliliters. It can be a little bit below that. You record your initial burette reading so that after you run the reaction, you record the final reading and just subtract to get the volume of sodium hydroxide that you used. But in number 2, you're doing question number 1 calculations backward, because you know the mass of KHP because you weighed it out and you wrote that number down. And you know the volume of sodium hydroxide solution that you're using because that's going to be the difference in volume in your burette. And so if moles of acid are equal to moles of base at the end point, you know the number of moles of sodium hydroxide divided by the number of liters that you used. Now you will have the concentration of sodium hydroxide to at least 3 significant figures. That's what you're trying to do in this part of the experiment. That is your standardization. And you need at least 2 results that are fairly close to one another, within 5%. After you've done the standardization, you're going to make the hydrochloric acid solution. And once again, that's a dilution. You need to do that appropriately. The last thing that you're doing is the titration again, but this time instead of KHP, you're going to have HCl solution dissolved in your beaker, and you have the same standardized sodium hydroxide solution. You refill it, and you do this titration again. Although this time, we're going to follow it with the pH probe. All right, the pH probe. The pH probe will need to be calibrated. There are pH 4 and pH 7 solutions available. Calibration is just the process of telling the instrument exactly what pH 4 and pH 7 look like. Once you do the calibration process, you're going to put the pH probe here in your acid solution, so it should start out looking pretty acidic. And you're going to follow the pH as you do the titration. Now, the way this works is that you are going to be generating what's called a titration curve, right, where the pH starts out low, and we look at these graphs, these titration curve graphs, where we're looking at increasing pH and increasing volume of base, and you're starting out down here somewhere, because the pH, it should be very acidic, because it's starting out in the acid, and we haven't added any base yet, so it's over here. And what you notice is that the pH kind of may go up a little bit, but it takes a while, And then suddenly the pH goes up a lot, and then it sort of flattens out again on the other side. The point at which moles of acid are equal to moles of base is called the equivalence point. And when we were using the phenolphthalein endpoint, that was the point where we had that light pink color. But now that we're following it with pH, we're looking for the inflection point in this graph. That's going to be that point right here in the middle. And because we're talking about strong acid and strong base, that should be right about pH 7. Now, what this means experimentally is that you can start by putting, say, 2 milliliters of solution in, and then stop, click keep on your LabQuest device, and write down the pH and write down the volume of base. Then put 2 more milliliters in. Stop, write down the pH, write down the volume of base. By that point, you may want to go to 1 milliliter. Because the further along you go here, the more the pH is going to change with the volume of base. And you've got to be careful because you don't want to jump through this middle part of the graph too quickly. So maybe you take 1 milliliter, write down the pH, write down the volume of base. Then 1 more milliliter, write down the pH, write down the volume of base. Then go maybe to half a milliliter. Eventually you want to go through this part of the graph, maybe 1 or 2 drops at a time. But you'll know because the pH is changing very quickly, get as much data as you can in this region. Then once you get on the other side of that, now we're pretty basic, right? We're beyond the end point. And now you can go back to adding greater volumes and you won't see as much of a pH change. So you're generating this curve. You'll use either Excel on the computers in the lab or the LabQuest probe itself to generate this graph. Our final goal here is to calculate the molarity of the HCl solution. And because we know the volume of base at the equivalence point, because that's what we can find on the graph here, right? The volume of base would be right here. And we know the concentration of the base to at least 3 significant figures. That gives us moles of NaOH, right? And at the equivalence point, at that point, it's equal to moles of HCl. Your moles of sodium hydroxide are equal to the moles of hydrochloric acid at the equivalence point. To find the molarity of the HCl, you just take your moles of HCl divided by liters of solution of HCl divided by the liters, and that should give you the molarity, and that should be everything that you need to know. Time can be a problem in this lab. You want to spend your time wisely. I recommend that you think a little bit about question number 1 before coming into lab, and then divide the lab into parts. And spend no more than, say, about an hour standardizing your sodium hydroxide solution, an hour making the hydrochloric acid solution and getting the pH probe calibrated. Then you can have the last hour of the lab for the actual titration of the sodium hydroxide with the HCl solution. And if you feel yourself being pushed for time and you need some additional help, be sure to ask for it. I believe that's everything you need for this lab. I hope you have a great lab.